Hi everybody, my name is Ivan, and today I'm going to share about corporate architecture and also about information security. You know, in my head, these two notions are separate notions. Because at first I was like security guy, I was working in corporate security department, and then I moved on to corporate architecture in the pure IT without any mixed of information security. So today I'm going to talk about how can we combine two of these notions and ideas, and I will try to do my best to be able to communicate this to you. But before we begin some practical part, I would like to give you a history of corporate architecture and also to shine the light on some dark past. Back in 70s and 80s, there was a very big development of IT technologies, and big companies, while implementing them, would get huge dividends or benefits. But at some point, strange things began to happen when by implementing yet another IT product, it would not give you any desirable and expected result. At the same time, you know, the companies were paying money for those IT solutions, and something had to be done with it. It was about money, and well, people were involved in that, and they began to understand that oftentimes IT solutions were very fragmented, isolated, you know, siloed in different departments, and even in two neighboring departments there could be like different software, which is basically doubling up, you know, doing the same function, and there was a very poor communication between all those installments. So it was like a very, very big disarray of the systems on one hand, and also they needed some methodology to be able to combine all these systems into so that they would be working great together and would be great. And well, despite identifying this like a core problem, they weren't able to find an immediate solution. And one of the big steps was the framework of Zachman. John Zachman was the author of this framework, and this was basically like a list of questions that you had to answer as you were building your corporate architecture. As a matter of fact, this principle looks like a Socrates method. Why? You have a bunch of questions that are more specific, that are visualized, and so on. And now, you know, this list of questions, like number one is, what I want to say is basically, there is no such a thing as universal architecture. And to be able to find good solution, you have to you have to, you know, come up with some weight, and you have to understand your target system, where you are, and find some unique solution for your system. And this list of questions is going to come very handy when you'll be doing that. But still, technologies were evolving, and back in 1990s, the community of architecture's open group, they came up with their own framework, which included their knowledge about corporate architecture and their previous experiences. They called it the Open Group Architecture Framework, TOGAF, TOGAF, whatever you want to call it, and the main goal of it was to become that missing technology or methodology, you know, which will help us to be the most efficient when implementing IT solutions. Well, let's look at it. Let's look at the main component of the TOGAF methodology. This is Architecture Development Method, or abbreviated as ADM. It's basically an integrated process which enables making some changes, architectural changes, and you can see this diagram on the right. It has 10 stages. Stage number 1 would be preliminary, where we are building or assembling the scope of terms of reference and assignments, and you know, just making basic project preparation. On the next stage, we are building our architectural vision, and in fact, this would be like just a draft of our target architecture. And after we have the draft, we can move on to the next stage, and this would be more detailed architecture. It is happening in 3 stages, and basically, like, one important thing about this TOGAF and also ADM method, that we always begin designing any system with business architecture. I mean, we describe business processes and we identify roles and so on. And only in the next stage, which would be the stage C, we are describing the logic of the application, integration between applications, a model of the data, and after that we are adding certain technological layer, where we describe some specific databases or infrastructure, like service, networks, and you name it. Right after we have designed our architecture, we can move on. We can move on to implementation, or should I say grounding of this abstract architecture into very specific systems and solutions. So each architectural solution in this cycle A, B, C, D, we find a specific solution. For example, it was like just a theoretical ACM system. Now we have to find some specific system, and even to the point of choosing something very like a brick and mortar. So it is not abstract anymore, it's very real. Now we can move on to planning. This is happening on the stage F of this cycle. Now, what do we do at the F stage? In the process of architecture design, we take our current architecture, then we take target architecture. On the F stage, we describe a specific transition from the current to the targeted architecture, and quite possibly that we may need some interim architectures to be added to be able to make this transition smooth and so on. And at the G stage, all these developments, they begin to into implementation. I guess it calls for special a project team. And architect stays put. He kind of walking from the sidelines of what is happening, how it's being implemented, and what the project team is doing. And lastly, the final stage of the cycle, it's right after the project completion, stage H. This is basically some kind of retrospect. You're looking back, an architect looks back, he or she is looking at how the project was implemented, they're describing it, documenting it, and then the cycle is over and we can move on to the next stage. Yeah. What else? What else we could identify in this cycle? This circle in the very center, it is not like a separate stage. It's about management. It's basically a reminder that at all stages of the main cycle, you have to take a look and to remember about some basic requirements and which have been predetermined, and also if needed you have to change them. Not everybody is willing to do that, but sometimes it's absolutely necessary. And the next moment you can see that all the arrows pointing one way on the cycle, so we always move from clockwise from A, B to C and so on. This TOGAF system recommends you to do it a bit differently. If you'll search it up on the internet, you'll be able to see some pictures of what stages could be cycled, done through several iterations. But what I like the most about this example, on the cycle DCD, whenever we do this detailed design of the architecture, we can do it on 3 stages. Number 1, we describe our current architecture, what it looks like today, and we kind of making a little thoughts about the future architecture. Next iteration, we describe target architecture, and the final stage would be just double checking that we do not have any discrepancies. Maybe we forgot some integration or whatever, so we're just making it smooth. What else can I say about this TOGAF model? Experience has shown that this is a very good system. This framework was developed in, I think, 1992. It's still been developing very proactively, and in fact, there is a very big proof that it's very, very efficient. But again, this whole case about the big number of stages, very detailed elaboration of this stage, I would say it's quite a high workload. It costs money, it costs some time, and you will have some schedule shifts whenever you implement it. So it's good to remember that this preliminary stage on the very top, I think it's one of the most important thing of all, because it is for adapting your framework. So whenever you go through this cycle, we have to do preliminary work and to understand what the stages will be, how big detail will be of describing, how much time is going to take. So to be able to control your prices on one hand, on the other hand, to be able to make it as thoroughly as possible. Yeah. Well, now, I think the theory part with TOGAF system is over, and before we will move on to the practical things, I would like to highlight another thing of the Open Group. It's ArchiMate. It's an architectural notation. It has been developed especially for us to be able to do this cycle. You can even have some kind of color coordination right here on this diagram. I'm not going to dwell on that. I only want to say that I like it for two reasons. It enables you to find some discrepancies between some gaps between maybe some over design, and you can also do it visually. You'll be able to look at that, and we're going to take a look at that using this as an example. Let's move on to practical example. Yep. This is quite a trivial example. It's from the information security world. Even though TOGAF methodology is very, very business-like, it's about business processes and so on. And I would like to show you today how you can use this model as well as ADM model for information security purposes and cases when you design defense system from a possible computer hack or attack. And if we begin our design, we should begin it with describing our business processes. And on the stage one of designing, we know only business process of this threat actor. We do not know where they're going to try to penetrate the system and so on. On the very top, you can see this bad guy, some kind of like just a made-up example. And two groups. One group is trying to get primary access, probably through mail-in spam, and the second group, the second team of attackers is basically implementing some inaccessible event and somehow it's trying to steal money. And to make this case more realistic, we can also add yet another layer of application, and then we'll be able to understand how it may be a reality with our infrastructure. Number one is spam mailing. They're using some specific mailing server and even some service of processing mail. Also, you can see a user right here, like the Anna was speaking about that before. Yes, and without the user, that would be very, very bad to implement this kind of hacking event. So by this stage of hacking a workstation, probably user is going to be involved because they're going to launch a certain code, and then at the stage of the second group of hacker after the first one is going to persist in the system and install remote access tool, and then on the stage of spreading through the group policies, they are implementing getting into the protected perimeter. Stage number 2, there is a client bank, and that's it. They're in the system. They've done everything in terms of protection. We've lost it. So this is a case, and I want to add this layer of applications, but also added the layer of infrastructure, highlighted in green boxes in the bottom. You can do it on a separate stage. But right here, they are playing as anchors for us to be able to see how this application system kind of overlaps the infrastructure. So we can add it because it is not that complicated. And okay, it's fine. We know how the attacker is doing. We have to move on to the stage of protection mechanism. And stage 1 would be a passive protection. Like historically, this was always the case, and also we can do it in the form of just a basic antivirus application or software. So this antivirus here in the bottom, workstation 1, you can see that there's a box of antivirus, which they do like the antivirus control, and they're double checking all the attachments which are coming through the mail client. And to be able to manage this, let's add the centralized antivirus server. And if you've noticed, things about the attack in hosts, it's highlighted in green boxes. Then antivirus management system is not green. In this example, it does not really matter where the infrastructure of InfoSec infrastructure is located, because it is not part of the system. We may not show it. But if we make it simpler, it's easier to read this diagram, of course. And right after passive protection mechanisms have been added, still there is a probability that those threat actors, by repeating their attack several times in a row, somehow they would be able to bypass our antivirus, or they will find a machine station without antivirus, or maybe they will use the social engineering or whatever. So what do we do? How do we counteract this attack? We have to control everything within the network perimeter, and to this end, of course, we can add a CM system. Well, in terms of architecture, CM would be a very simple thing to do, because it has 3 main components. It's collecting events, I mean a certain engine which is collecting events from systems. For example, we have a mail server, which is part of managing antivirus and also domain control. And next, it has a certain interface to be able to provide these events as certain analytics, and also a correlation engine, which will be automated process, which simply taking the flood of events and then pulling out different incidents, putting them together, and give us some signals that there is a problem or security breach. Yeah. Well, and right after we've made the design, we've added CM, we have the flood of events. We have to analyze those events, take them apart, and also to respond to them. And to this end, right now, we're going to go back to this level of business processes highlighted in yellow, and we're going to make our response business process. Well, at the very bottom, you can see this business process added and its description. This is how we are going to respond to an incident. I've added right away this also SOAR system as, like a class of solutions enabling us to simplify and automate certain processes related to the investigation and response. It is not complicated, because in this case the process starts with incident registration. We simply identify certain ID to this incident, it begins to live in our system, and then we, on the next stage of our initial response, the first line is activated, they evaluate incident in terms of it was like a false positive or true positive, and then they can use SOAR mechanisms manually, but probably the first line of defense will do certain actions to be able to counteract this attack. For instance, my favorite is isolation and blocking, what the InfoSec guys, love. Next, we have the second line of defense on the stage of investigation. They're using this mechanism of events analyzing in CM and probably in SOAR. They're also having certain tickets, and they can it can be used to look at the scope of incident, at the story of the incident. They begin investigation, and if they can find a certain attacker, they can move on to the next stage and do some reaction, either via SOAR or through with like IT guys that can do it manually, basically.
Reacting, investigation, etc., out of which we can come out if we understand that it's the end of the incident. Malicious actor does not show up, and then we go and remove the consequences. Removal of the consequences is the responsibility of the IT department. The SOC part participates only as observer. IT unblock the accounts, change the passwords, reinstall the OS, and something like that. And at the final stage, ticket comes back to the first line. We close the incident when the first line is being checking that all formal procedures executed and the incident can be closed, and then we can go to the next stage. I've been describing this example by saying that, well, it's a very untypical situation for TOG to be involved in designing systems like that. And for the enterprise architecture, which is usually involved in different things, it's unusual ticket. It's a very hooligan type of an example. However, when I've completed this example, I've understood suddenly that there is nothing supernatural here. That stage number one, usually it's called threat modeling. We have evaluated the actions of the criminal actor. We have tried to put a graph how he is going to act. Then we put down this incident to our infrastructure of application stack, and we have understood which applications he's going to work with. After this, it was a really understandable story. We add means of protection. We understand what has to be journaled, etc., etc. Passive protection, anti-protection, something like that. And this particular example, I really liked it. That's why I have included my presentation. And to my point of view, it has several advantages that I can speak about. Advantage number one, and which is very important, it precisely shows the logical connections. Why do you need to collect logs? Why do you need to send them to CM? Why should we automatically react to the test blocking of the accounts?
Второй момент. Здесь, на самом деле, в деле в таких схемах очень хорошо видны пробелы проектирования.
On these schemes, you can see the gaps of design. For example, if you look at the stage number 4, money theft, all the systems which are located there, they are outside of information security system. So if the criminal will get into this perimeter, it means we're lost and we will never find about it if we have not reacted previously, and we won't have any possibility to counteract. So looking at this particular scheme, we can go to another iteration of countermeasures, and then we can add the mechanism of protection, at least collect logs from these particular things, something like that. Well, another thing that I would like to tell you about, it's not really obvious, but if you look at the top part here, the action of the group and business processes that were described, honestly, this language looks like regular description of regular business processes. It has RCA, RASI matrix. Well, it's a language of theoretically, it's going to be understandable by business. And business, if you will come to the business with this diagram and say that, well, the malicious actors will act like this, we have certain conclusions, what should be added, what should be deducted. Business might agree about this because everything is very logical. It should be like that. And I think it's going to be the end of my presentation. Now I can go to conclusions.
Да. Ну, мы, кстати,
Yeah.
начали с вами
By the way, we have started by saying that universal architecture does not exist. So in order to make effective solutions, we need to look at real capabilities and demands, our demands, and our possibilities, and demands and possibilities of the malicious actors. We have to be in some kind of a
я уже говорил, что TOGAF крайне сложная методология.
countermeasure mode, but it's a very complicated methodology. It's very costly in realization, and we've been looking at a very simple example, but the scheme is going to be pretty big. That's why
Его важно адаптировать
it is very important to adopt it to a specific project, to a specific objective, and pay great attention to it. And there's another peculiarity here that architectures, and there's one book that tells me that any architecture that you're going to design, no matter how detailed and great it is described on the paper, it's still a hypothesis. And in the process of its realization, it can be confirmed only when you realize it in real life. And the final idea that I have, I just came up with it just recently. I've been speaking about universal architectures. They don't exist, but there's also no universal methodologies, and you should always try to find something new through questions, answers, ideas, thoughts. That's all I wanted to tell you. Thank you very much. Okay, it's a Q&A. We have 5 minutes for questions and answers. Please ask them. And go back to slides. Yeah, can you return the slides, please?
Да, в первом ряду.
Yeah, the first row. Pavel Kuzminych, you just told us that removing the consequences of the attack, IT department changes the roles, codes of access, etc. But I have an architectural question. How the IT department should be involved in dividing the access levels and control of the resources and password policies, because this is not their responsibility. Good question. Well, my recent answer was that there is no universal methodology, and everything depends on some context, how it is organized. Can you allow yourself to trust IT department to be confident in their competencies so that they would be able to do that? Because IT people, you still have more IT people, and they need to have good specialists with good background. And I don't know, my main direction is safe development. And there's a concept, shift left, when you are trying to take all the security tasks. In case of development, you transfer responsibility, product safety to the developer of the product. Our function is just control function. And with regular security, we are trying to give it to the IT department. However, everything depends on how adequate and how competent are those people and how they show themselves. Okay, thank you. Well, I have a small question. Are there any other tools? Arch is the most effective method of providing the IT infrastructure. Well, I'm not really able to judge. C4 is used, and there's a connotation like that. This is also very detailed, multi-level. However, I don't use it pretty often, so I don't know how to recommend it or not recommend it. I cannot do that. Honestly, speaking about corporate infrastructure, well, it is very important to use the proper approach, not the tool. Understanding how we move, how we develop, all these visualization tools, they are needed. Well, their usage depends on who is the target. If you are making it for yourself, yes, there's ArchiMate, which you can use to find some deficiencies and problems. If you move it and give it to top management,
как бы мог глаза на лоб.
ArchiMate,
Поэтому
sometimes, their eyes can pop up because of the ArchiMate. So you need to make and visualize it more beautifully, more understandably.
визуальные красивые картинки.
Maybe use
Ну или
some
VPN.
more beautiful visual
То,
picture,
с чем они умеют работать, по крайней мере.
things they know about. So, thank you very much.